This is BBC Radio 5 Live.
Thank you, Nikki. Hello, good morning. It's 10 o'clock on Tuesday morning. This is Victoria Derbyshire on 5 Live, and this morning in a broadcasting first, I'm at an animal research centre in Oxford. We've come here to look at the scientific research that takes place using tens of thousands of mice into some of the biggest health problems facing Britain: Alzheimer's, obesity and diabetes.
Our role here is to understand the relationship between genes and disease. We know that most diseases have a genetic component, so if we can find out what genes are going wrong, then that gives us new opportunities for therapies and new opportunities for healthcare. What we're doing is using our most powerful route to understand that relationship between genes and disease, and that is the mouse.
50,000 mice are kept here at any one time. 2,500 of them are killed every week.
There's two really methods that we can use. One is cervical dislocation, which is actually breaking the animal's neck. It sounds a bit sort of, breaking the neck, but it is very quick, and it's the method preferred by the technician. So we take the animals out of their home cage, we take them away from the other mice, and we break the neck very, very quickly. The other method we can use is the method that would happen if you took your animal to your pet to the vet or something like that, where we can give an overdose of anaesthetic. But sometimes what it does, it affects the blood chemistry, so it can actually have an effect on the science by using these overdoses.
Over the next couple of hours, we'll find out how scientists here create their own mice. We'll observe some of the tests being carried out, and we'll speak to those who say that any type of testing on animals is morally wrong.
In the case of genetically altered animals, there are some special ethical and welfare issues. Painful procedures are involved, animals are wasted, and the kind of conditions they can end up suffering from can also cause them pain, suffering and distress. That's why it's very important to recognise all the harms that may be caused to animals and ensure they're given fair weighting when making decisions about licensing research on animals.
An opinion poll commissioned for this programme by Comres suggests that almost 1 in 3 adults in Britain think the government should ban all forms of medical testing on animals. We'll bring you more details on that too throughout the programme, and we'd like to hear your views as always. 0500 909 693, text 85058, and you can also find me on Twitter. It's the first time, as far as we know, any lab like this has allowed a programme to witness live the kind of work that goes on here. Right this second, we are in the micro-injection laboratory. It's quiet, it's warm. It has a sort of vaguely sterile smell, but certainly nothing unpleasant, and there are various micro-injectionists sitting in front of us doing their work, which we will describe in a second. The reason that we're here is to look at some of the research that's taking place using thousands and thousands and thousands of mice. Research which scientists hope will help reveal how and why we, as human beings, get conditions like Alzheimer's and diabetes. This is not a place where scientists test new drugs on mice. This is where scientists create their own mice, and we'll explain how in a second. The mice they create have had their genes altered to give them diabetes or Alzheimer's, or to make them obese. So they are in fact genetically modified mice. And researchers hope that if they can ultimately identify the genes which cause, say, diabetes, they will be able to work towards new therapies and treatments. But it's a very, very slow process and can take decades. So on the programme this morning, we're going to look at that process, how genetically altered mice are created. We're going to look at some of the different tests that take place on the mice here. Throughout the whole programme, we'll be asking why, of course, and later we'll hear from those opposed to using mice in this way. But first, a couple of facts. The genetic makeup of mice and men is very, very similar. Humans have around 20,000 genes, and so do mice. And 99% of our genes are exactly the same, which is obviously why mice are so useful, scientists say, for their work. The latest Home Office figures show that nearly 3,700,000 animals were experimented on in UK labs in 2011. Of those, nearly 2,700,000 were mice. The remaining million were mainly other rodents, birds and fish, although 153 cats, nearly 3,000 dogs and about 1,500 monkeys were also used. Animal rights campaigners say not only is any form of animal testing morally indefensible, it's also unnecessary and with questionable results. OK, so we've just seen the diabetes cells go into that embryo. What happens to that embryo now?
Now we've transferred the cells into the embryo, we need to implant them into a female mouse so that we can render her pregnant, and she will actually carry those embryos through to term and give birth to some baby mice.
Right. And how long does it take from implanting the embryo for the mouse to have her pups?
In this particular procedure, it'll take between 17 and 18 days before the pups are born.
Okay. And where have you taken the embryo from?
Well, the embryos were actually harvested yesterday. They were collected from female mice that were mated. They're actually superovulated like one does in a human IVF clinic. So we'd superovulated the mice, and then we'd collected the embryos from female mice yesterday. We'd cultured them in the incubator overnight so that they then developed into this particular stage of embryo that we can implant, which is effectively a hollow ball of cells called the blastocyst.
Okay. And once the mouse gives birth to the pups, what will you do with the pups?
This is the exciting stage. So we're actually injecting black cells collected from black mice into embryos that have been collected from white mice. The pups, when they're born, or that's the baby mice when they're born, they're actually naked. But after 4 or 5 days, the coat colour comes through, the hair starts to come through, and we get our first indication that the projects have been successful because we can see patches of dark and white fur, and this is very good news for us.
And how is that relevant to diabetes, though?
Well, what we actually need to do in this particular diabetes model is establish a colony of mice that can then be passed on to the researcher.
Yeah.
And we need to do this. We need to make sure that we can pass this diabetes gene from one generation of mice to the next. So we have to mate the animals, and we actually test the pups that are born, the progeny, to see that they're carrying this particular gene. And once we've confirmed that they're able to carry the gene, then we can pass on the mice to the researcher.
Okay, and that's when they'll start doing various tests, and then the results are taken from that, and the scientists trying to work out what the results show.
That's exactly the case. That's exactly.
What we should make clear, though, is the embryo, the female mouse from which you've taken the embryo, is killed before you harvest the embryos.
That is correct, yes.
Okay, let's take us over to the other side of this lab, which is about the size of a large office. You'd probably be a CEO if you had an office this size, I reckon. So we go to the other end of the lab, where you are going to show us how you kill a mouse.
Exactly.
Sorry, go on.
I was going to say this is an essential part of the process. We've got a technician in front of the laminar flow hood at the moment.
Before you do this, just explain why you have to kill the female mouse first before you take the embryos out of her.
Yeah, okay. So we've had to superovulate the mice, which is a regulated procedure. We can only use mice once. So the most...
That's part of your licensing.
It's part of licensing, exactly. It's part of the licensing agreement. So the most efficient way of operating now is to kill the mice. It's very quick. It's a humane procedure, and this allows us then to take out the uterus and then flush the embryos from the uterus. These embryos are then incubated overnight and then injected the following day.
Right, so why couldn't you put the mouse under anaesthetic and take the uterus out, and then the embryos, put the uterus back and bring the mouse back to life, as it were?
Well, as I say, we're permitted to take one procedure, subject the mouse to one procedure, and that's the superovulation procedure. The anaesthesia itself, although just put
the licensing stuff to one side.
Yeah.
Is there any particular scientific reason why you couldn't do it in the way I've suggested? Is it because the uterus is too small, or it's too fiddly, or it's just not worth it because it's only a mouse, or what?
Well, it's certainly not the case that it isn't worth it because it's only a mouse. The body parts of a mouse, of course, very small, and all the dissections have to be done under a microscope. But for practical reasons, it doesn't make sense to anaesthetise mice, to harvest the embryos, and then keep them and then transfer the embryos back into those individual mice.
It doesn't make sense to who?
Well, it doesn't make sense ethically to do this because we're subjecting these individual mice to quite an extensive range of invasive procedures, and this is, of course, not what we don't want to do. So we try and separate the superovulation. The mice are injected, they're superovulated, we then kill the mice, the embryos are harvested, say, cultured, injected the following day, and then we get separate mice that we can then anaesthetise, and it's these the embryo recipient mice. They've only had one procedure, and we believe that to be a more ethical approach to the type of experiment that we're doing.
All right, so we have here one of the technicians or microinjectionists.
Yes,
you're nodding. It's one or the other. Yes. Okay. And just let me, in a sort of larger than a shoebox size, slightly larger than that, plastic, transparent. You call them cages, but that gives the wrong impression, I think, to listeners, because there's no metal there and they're not cages. It's a big plastic, transparent box, and inside there we have 4 tiny white mice. And you're going to show us, and you're going to describe, if that's all right with you, Dr. Frey, what your technician is doing.
Yeah.
Here.
So what the technician is doing is now we're picking the mouse up by the tail from the cage. She's allowing the mouse to grip on a cage top, and this stabilises the mouse. And then she's very quickly going to grasp the neck of the mouse and break the neck. In fact, it's a process we call cervical dislocation. So it's very quick, and she'll do it now. There we go. And that is it. No.
So what the technician did was, and the mice is still kicking, I have to say. The legs are and it's still moving.
So this is a nervous reaction. The neck has been broken and the mouse is dead, but yes, there's some nervous activity, and the back legs are kicking, but they've stopped now.
Well, how do you know that wasn't sort of 12, 13 seconds of absolute pain as the mouse was dying?
Because we'll give you the opportunity to feel the break of the neck. The neck is completely broken and been severed from the collarbone. So we know precisely that mouse has died, and it died instantaneously, despite the kicking of the back legs.
Okay. So what the technician did was hold the mice with the tail in her left hand, and with her right thumb press down on the neck effectively. Yes. So dislocating the spinal cord from the brain.
Effectively.
Yes.
Effectively. That's exactly what happens.
Okay. All right. Okay. Right. Let me read some messages from our listeners. Bruce says, I think the use of animals is absolutely abhorrent. Not only that, I think it's detrimental to our own evolution and indeed survival. Is it any wonder that we are the most violent and destructive force on this planet when we feel we can exploit, torture and kill at will?